Hey everyone, so we are starting the second half of the quadratic unit. So now that we know how to solve quads, we are now going to go ahead and graph them. So start by doing this do now. This is an SAT question. So it says, what is the sum of the solutions? So what are the solutions? So for each of these, we set them equal to 0. Plus 6, plus 6. That's the saddest 6 I've ever seen. So we get x equals 6 minus 0.7. And we get x equals negative 0.7. So those are our two solutions. And then what's the sum of them? 6 plus negative 0.7 equals 5.3, which is C. So the nice thing about the SAT, the current SAT, is it really is based on what you learn in class. Okay, so we are going to graph x squared. This is called the parent function because it's the most basic quadratic we can have, right? We can't get any more basic than just x squared. So we're going to plug some numbers in. So a good rule of thumb when you're graphing is to kind of get some negatives, some positives. So I'm going to plug in 0, negative 1, negative 2, 1, and 2. And whenever you make a table, you're supposed to have smaller numbers on top, bigger numbers on the bottom. So we're plugging into x squared. So that's a negative 2 squared, negative 1 squared, 0 squared, 1 squared, and 2 squared. So we're just plugging into the equation, and we get 4, 1, 0, 1, 4. So now let's plot them. Negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. And then we could even do negative 3 and 3. 3 squared is 9. Negative 3 squared is 9. So this is my graph. So this is what a quadratic looks like. And this is the parent function. So every single parabola will look like that. It can get stretched. It can get flipped upside down. It can get skinnier. It can get wider. So there's lots of stuff can happen to it. But that is the most basic function. Kind of like if we had y equals x, right? Y equals x is the parent function for a line. Okay, so now we're going to do the same thing. So I'm going to actually tell you the x's, though. Here's the numbers I want you to plug in. 2, 1, 0, 3, 4. So I want you to pause the video, and you're going to plug into the parabola x squared minus 4x minus 5, and figure out those y values. All right, so I got some plugging in. And feel free to use the calculator to figure these out. So for 0, we get negative 5. For 1, we get negative 8. For 2, we get negative 9. For 3, we get negative 8 again. And for 4, we get negative 5. So 0, negative 5, right there. Pretty much all of these also are 10 by 10s, so I kind of can skip. I don't really count very closely. And then we can plug in 5 if we wanted. So that would be 25 minus 20 minus 5, which is 0. Like we can plug in more numbers. And there's our parabola. So now here's the thing. Notice I gave those numbers to you. How do we know what points we care about? Because what we don't want to do is plug in like points around there. Then we would end up graphing a line. We want the bottom part. We want to make sure we're plugging in numbers around the bottom. So we have a formula that we're going to use to figure that out, right? Otherwise, we're just going to start plugging numbers in and just hoping for the best. Okay, so a parabola. This curve is called a parabola. The name of the U-shaped curve created from the graph of a quadratic function. And sometimes I write y equals, and sometimes I write f of x equals. F of x is the same thing as y, so don't freak out if you see f of x. I know we haven't gone through that quite yet, but it is a thing, and it's just the same thing as y. Okay, the vertex of a parabola, the vertex is this bottom point or top point. It's the minimum or maximum of the parabola. Right? The minimum or maximum point of a parabola is called the vertex. It's also called the turning point. And there's actually a formula to find it. Negative b over 2a. Notice that should look semi-familiar. That comes from the quadratic formula. Remember the quadratic formula? Negative b plus or minus. So it actually, if you negative b plus or minus the square root b squared minus 4ac all over 2a. If we completely get rid of the square root, negative b over 2a is our formula to find that vertex. So finding this point is important because that gives us an idea what numbers we care about. We want the numbers around the vertex on either side of it, right? This one, I want the numbers around it also. Okay, so whenever we graph a parabola, the very first thing we do is negative b over 2a. So negative b over 2a. So I'm going to look at my formula. What's my b value? Right? A is 1, b is negative 2, and c is negative 3. So I've got negative 2 over 2a. So we get 2 over 2, which is just 1. So that 1 is going to go in the middle of my table because we want the points on either side. Remember, it's going to look like this. So this is the 1, and then I want some points on over here and over here. So the 1 goes in the middle, and then I'm going to go to smaller numbers, 0, negative 1, and then 2, 3. All right, so now we're going to plug into x squared minus 2x minus 3. So pause the video and plug in and see what you get for your y values. So we get negative 1 squared, 2 times negative 1 minus 3, 0 squared minus 2 times 0 minus 3, 1 squared minus 2 times 1 minus 3, 2 squared minus 2 times 2 minus 3, and 3 squared minus 2 times 3 minus 3. So let's see, we get 1 plus 2 is 3. 3 minus 3 is 0. We get negative 3 here. Plug in 1, we get 1, negative 4. Plug in 2, we get negative 3. Plug in 3, we get 0. Okay, so now plot those points. So I get negative 1, 0, 0, negative 3, 1, negative 4, 2, negative 3, 3, 0. And then again, we can extend it if we want to plug in 4, we want to plug in negative 2, we could do that also to get some more points on this graph. Now, take a look at the y values and tell me what you notice. On all the problems so far, if you look, the vertex is in the middle. What's happening on either side? They're repeating. That's how you know you did the problem right. If that happens, you did it right. That should always happen because parabolas are symmetric. We're going to get into that in a little bit. Because of that symmetry, the y values repeat because they're the same distance from the vertex. So if you get weird points for your y's and that's not happening, you know you made a mistake. Okay, look at the graph. What's the y-intercept? The y-intercept is where your x value is 0. So our y is -3. Our x-intercept, so where does this cross the x-axis? So where our y is 0, we got -1 and 3. So those are important points on the graph: the parabola, the y-intercept, and the x-intercepts. Okay, so I just was talking about the symmetry of the graph. So all parabolas have an axis of symmetry. All right, an axis of symmetry is a line, a vertical line that cuts the parabola exactly in half. Remember symmetry from geometry in middle school, like the letter A, for instance, has symmetry down its center. Same thing with a parabola. A vertical line cuts through the parabola. A vertical line is always x equals. All right, that's super important. If you tell me the axis of symmetry is 7, that's not okay. It's x equals 7. It's a line, a vertical line. So, and notice it always goes through the vertex. So it's pretty simple. Once you know your vertex, you know, like this is 3, -4. So then I know my axis of symmetry is just x equals 3. It's whatever the x value of the vertex is. We could fold our parabola exactly in half. All right, so I want you to pause the video and try this one on your own. So we're going to start with -b/2a. Oh, I forgot to change my table. Okay, so I got -4 over 2 times -1, right? A is -1. I get -4 over -2, which is 2. So 2 goes in the middle. 1, 0, 3, 4. So we're going to plug in. If I plug in 0, I get -5. If I plug in 1, I get -1 plus 4 minus 5, which is -2. If I plug in 2, I get -4 plus 8 minus 5, that's -1. If I plug in 3, I get -9 plus 12 minus 5, which is -2. And then I'm going to get -5. So again, notice that symmetry happening. So we have 0, -5, 1, -2, 2, -1, 3, -2. All right, so, and then we did have that symmetry, which was good. All right, so AOS is my axis of symmetry. So that's x equals, what's the axis of symmetry? It's just 2. My y-intercept, that's where it crosses the y-axis, 0, -5. Where does this cross the x-axis? It doesn't, so we're just going to put NA. Okay. Again, we have that symmetry happening. And please use a calculator. Don't try plugging these numbers in your head. Use a calculator. All right, last one. Same idea. Pause the video, try it on your own. -b/2a. -6 over 2 times 3. -6 over 6 is -1. -1, 0, 1, -2, -3. All right, I'm going to plug the easy one in first. -5. Let's see, plug in 1 and we get 4. Plug in -1, we get, let's see, 3 minus 6 minus 5. It's a -8. -2, we should get -5 and 4. All right, let's see what this looks like. -3, 4. -2, -5. -1, -8. 0, -5, and 1, 4. So notice this looks a little different. It's skinny, right? That's a skinny graph. So what's my axis of symmetry? X equals -1. Remember, it's the vertex. My y-intercept is 0, -5. What's the x-intercept? Right? If you look, it crosses at some weird point. We don't really know what they are. So let's estimate. We'll go over finding the actual answer. So it's about 0.50 and negative 2.50. We'll go over in the next lesson how to actually find the exact answer. All right, so that is graphing parabolas using tables. So negative b over 2a, go through, make your table, etc.